Hello, we're going to look at how you generate electricity. Where does your electricity come from? How does it get to your house? We need to know how all our electricity is produced in our country. And actually it's just produced using a wire and a magnet. I've got a horseshoe magnet here and a little piece of wire. Now this is quite difficult to see, so I'll try it quite carefully. So I've got my wire and all it's connected up to is a sensitive meter. And you can see, if you look closely at the meter, that when I move the wire through the magnetic field, there's just a little twitch on the needle. Tiny. It goes one way when I move it in, and it goes the other way when I move it out. So by moving it in and then out, I can produce a very, very small alternating current. Now, one way to get it a little bit better is just like you would make the strength of an electromagnet stronger. What I need to do is have more coils. So if I wrap this wire round until I have 1, 2, 3 turns on it, hopefully we'll generate a little bit more electricity because all of these wires will add up. So let's try it. Move it in, much more. Move it out, lots more. So by having 3 turns, we get 3 times as much. Now this is a voltage. The wording is very important here. When a wire moves in a magnetic field, a voltage is induced. Induced just means made to happen. If you move it one way, the voltage is induced in one direction, and if you move it the other way, it's induced in the other direction. And it makes a difference how many turns there are, how strong your electromagnetic field is, and also how fast you move it. If I move this really, really slowly, we don't get much at all. But if I move it quickly, we get quite a big flick on that needle. But 3 turns isn't really very many. So what I'm going to do is I'm going to change how I do this, because it doesn't matter whether it's the wire moving or the magnet moving. It has exactly the same effect. So instead of having 3 turns and my horseshoe magnet, what I'm going to do is to use this big coil. Now this has a lot more turns on it. So if I connect this in its place, I'm actually using a weaker magnet. But because I've got so many more turns here, you can see the effect quite quickly. So when I move it in, the needle flicks one way, and when I move it out, the needle flicks the other way. And as I said, it doesn't matter whether it's the magnet moving or the coil moving. They have the same effect. When I move the magnet into the coil, what I'm actually doing is making the field around that coil stronger. And then when I move it out, I'm making the field weaker. So I'm making the field stronger, weaker, stronger, weaker. The same if it's the coil moving rather than the magnet. So the real explanation for this is that when a wire is in a changing magnetic field, going weaker and stronger, a voltage is induced in it. And that's how we produce all our electricity. Can you tell what type of electricity is being induced here? It's going to be AC because it's changing direction each time rather than always going in one direction. That sort of movement isn't very easy to do. Up and down isn't a natural movement. We can actually get the same effect using a little device like this. Now here, instead of having a single wire, what we have is a coil of wire, and we spin it in a magnetic field. Here are the 2 magnets that we have. And this actually produces electricity, and this is the main way that all our electricity is produced in power stations. What we do is we heat water, which turns to steam. You've seen the steam rushing out of your kettle. It comes out with such force that if we put that down a very narrow pipe on a much larger scale, there's enough force to turn a turbine, and it turns a generator, which is just a wire turning in a magnetic field. And that produces all our alternating current for the whole country. You've heard of this before when you've looked at your energy resources and looked at generating electricity. A lot of our ways are made by spinning coils of wire in magnetic fields. We have wind turbines, we have water turbines, we have turbines in power stations, coal-fired, gas-fired and nuclear power stations all use this principle of a wire turning in a magnetic field coil of wire turning in a magnetic field to generate all our electricity.